Hey everyone, welcome to the second part of your review packet. Today we are looking at absolute value functions. So remember, an absolute value function is a type of piecewise function because it has different rules for different parts of the graph. It goes down and then back up, or up and then back down, and is facing, excuse me, and is forming a V. It has a facing up, open up, V if the coefficient is positive, and a facing down V if the coefficient outside of the bars is negative. This is the equation that it typically follows, and our vertex is h comma k. Remember that h, that negative, is part of the formula. So if it is a positive, that means it's actually negative, and if it's a negative, it's actually positive. So let's look at this one here. Let's rewrite this. F of x equals absolute value. Now I'm going to rewrite the inside so that I can see what the coefficient of x is. So I'm going to rewrite this like this. This is a little bit confusing because the x is written second. That negative goes with the number it's in front of, so it is going to be written as such. All right, now thinking then about the vertex here, this means that we have a vertex of h over a, so this would be 6 over -3. Remember that this is really a -6, so -6 over -3, which is 2, 6. Let's take a look at what this looks like if we graph it. So if I go to y equals, let me clear this out, it's from before, and we're going to go ahead and put in our absolute value bars. Oops, that's not the absolute value bars. Hold on, give me a second. So absolute value is, we go to math. Sorry, I did that already. Math, and then we go over to number and hit absolute value. So absolute value bar is there, but I want that to be in here. So we're going to do math, number, absolute value, negative 3x plus 6, and then plus, yes, plus 6 outside of the absolute value bar. All right, so then we're going to graph it. Oop, I also still have this on this. Let's change that to a line. There we go. Let's get a thick line. Here we go. Graph. Okay. Oh, I guess I didn't save that. Okay. Oh yeah, I didn't press OK. There we go. Okay. Okay, graph. All right. So now it is going to look like this. And so if we zoom in here, let's zoom in a bit. We can zoom even more. Right, and we can see that this is 2, 6, which is our vertex. So 2, 6 is our vertex. We're going over 2 and up 6. That's our vertex, and it is open up. Okay, and we know that it's open up because even though there's a -3x here, anything in this bracket is going to then become positive, right? So it's not going to go back down, it's going to continue to go up. If that negative was outside of the absolute value, then it would flip upside down. But because that negative is inside the absolute value, anything that comes out of that absolute value will be positive. And so this will be our equation. Now, worst case scenario, if you're like, oh my gosh, what do? You can plug in numbers for x. So if I plug in 0, right, I would get 6 minus 0 is 6, so 6, 6. That's a point I can plot. And so you can plot multiple points if you get stuck, and that can help you to figure out what you need to do here. Okay, the key point here is I needed to rearrange the inside of the absolute value, and then I'm looking at h divided by k gives me the x value of the vertex, and then k out here is our y value of the vertex. So let's look at this next one here. This one, we have the negative outside, so I know it's going to open down, and again our vertex is h over k, so this is going to be 6 over 2 is 3. So 3, 1 will be our vertex. So 3, 1 is our vertex, and then it's open downward. And again, I can plug in, if I plug in 2 here, for example, I would get 4 minus 6, which is -2. It becomes a positive. -2 plus 1 is, sorry, this becomes -2 plus 1. It's just -1, so this would be down here. that means there'll be another point on the other side over here, so then you can draw your line as such, okay? And again, if you wanted to check, you can go into your equation, you can graph negative, math, number, absolute value, 2x minus 6, 2x minus 6, and then we're going to add 1 on the outside graph, and so you can see that that is what it looks like there, okay? All right. So changes in HK translation. So H, which is inside of your modulus bars or inside the absolute value bars, moves the graph left and right, and plus K moves the graph up and down, okay? So how is the graph, second graph, different from the first graph? So it's different from the first graph in that it moved right and flipped down. It says how many units left or right did it move? So it moved 1 right, and then up down it moved down 5. And we can see that here with a 6 and a 1, right? So the vertex moved down. All right. Multiplying binomials or FOIL. So this is what we've done more recently, where when we have binomials such as this, we need to multiply every part of it. We can FOIL or use the box method. So using FOIL, I'm going to do first, I get negative 8x squared. Let me change this pen. I'm not really, it's hard to see. All right, so negative 8x squared. And then outer, so negative 2x times negative 2 is positive 4x. Inner, 1 times 4x is plus 4x. And then last, negative 2 times 1 is negative 2. You can combine that to be negative x squared plus 8x minus 2 is our answer. Now here I'll model using the box method. So negative 1/2 x minus 2, 6x plus 8. All right, so 6 times negative 1/2 x is 3x squared. 6x times negative 2 is negative 12x. 8 times negative 1/2 x is negative, oh, actually, I think I should have, this is negative 4x, and then 8 times negative 2 is negative 16. Then you can combine your like terms. So we'll have negative 3x squared minus 16x minus 16. All right, the difference of squares. So when we multiply the difference of squares, it cancels out the middle term, and we only have the first term and the last term left. And that's because we would get here 4x squared minus, plus 4x minus 4x, right? Outer plus 4x, inner minus 4x, minus, minus 4, or 4x squared minus 4. So if you see the difference, right, the difference meaning subtraction, between two perfect squares, that means you have a difference of squares and that middle term has been canceled out. So factoring this, you could also recognize that if we were to work backwards, that this would be 2x minus 2 times 2x plus 2. Over here, we're going to get x squared plus 3x minus 3x minus 9. So again, you get x squared minus 9. And that middle term gets canceled out. We have a perfect square and a perfect square separated by the difference, right? The difference of squares. And so you should also recognize that when you factor, this will go into x plus 3 times x minus 3. All right, factoring. When we factor a quadratic, we look for the factors of c that when added equal to b, meaning what times what will give us our last number or our constant that will add together to give us our linear or middle term, right? So this then is what you can use to help you figure out those factors when we don't have a coefficient of x, so when we have a more simple one. It says choose the expressions that are equivalent to x squared plus 4x plus 3. Well, to do that, then I need to figure out what each of these are. So I'm going to rewrite this as x plus 2 times x plus 2 minus 1, which will give me x squared plus 2x plus 2x, so plus 4x plus 4 minus 1, which gives me x squared plus 4x plus 3. So this is one of them. Seeing that this gives me that, then I can deduce that this will not be an answer because it would be adding 1 to that, which would be 5. Here, I'm going to go ahead and FOIL. So I'll get x squared minus 3x minus x plus 3. So this is minus 4x. That's not going to work out. I can probably deduce that this will, but we'll say x squared plus 3x plus x plus 3. That is true. That is equivalent. And then here we get x squared minus 4x. Oh, sorry. Nope. Outside. So plus 4x minus x minus 4. We're close here, but not quite, because we get a minus 4 for our constant term and we have a plus 3, so that is not it. Down below it says factor and solve for the 0. So I need to think about what two numbers multiply to give me negative 3, but add to give me 2. 3 is a prime number, so it's going to be 3 times 1. And I want it to be a positive 2, so it'll be positive 3 and negative 1. This will be x plus 3 times x minus 1. And then solving for the zeros means that I set each factor to 0 and solve for x. So x can equal negative 3 or x can equal 1. All right, now when a is not equal to 1, remember we multiply a times c, find the factors that add up to b, and then rewrite it in your boxes for factoring. So let's do that. So 2 times 12, oops, actually we have to rewrite this equation. Got a little ahead of myself. So 2x squared plus 18 equals 12x. Let's rewrite this as 2x squared minus 12x plus 18. So multiplying a times c, we get 36. I need factors of 36 that are going to add up to equal negative 12, but be multiplied to get positive 36. So the numbers will be negative 6 times negative 6. So I'm going to rewrite this as 2x squared minus 6x minus 6x plus 18. And then I'm going to reverse factor, right? So 2x squared minus 6x minus 6x plus 18. Here I can take out a 2x, take out an x here. This will be minus 6. And then this will be minus 3. All right, so then I now have my factors of 2x minus 6 times x minus 3. And you can go forwards and check to make sure that that works. But you want to check to make sure 2x times x is 2x squared. X times negative 6 is negative 6x. Negative 3 times positive 2x is negative 6x. And negative 3 times negative 6 gives us positive 18. Then if I needed to, I could solve by setting these each equal to 0. All right, let's try this one. A times c is negative 24. Factors that equal multiply to give us negative 24, but add to give us positive 2 are going to be a positive 6 and a negative 4. They multiply to give us negative 24. They add to give me positive 2x. I'm going to rewrite my equation. 8x squared plus 6x minus 4x minus 3. And then we're going to reverse factor. So 8x squared, 6x minus 4x minus 3. Here I can take out 4x. What will be left is an x. 2x here. So this will be plus 3. And this will be minus 1. Right, because negative 1 times 3 is negative 3. Negative 1 times 4 is negative 4x. 2x times 4x is 8x squared. Yep, so that works out. And so my factors are 4x plus 3 times 2x minus 1. All right, solving for the zeros or the roots give us our x-intercepts. So once you factor, then you set them equal to 0, and that helps us to find our zeros or our x-intercepts. So it says the graph of these two equations intersect in the xy coordinate plane. What are the points of intersection? Enter your answers in the boxes. So it's asking us when are these two equal. So I'm going to write them equal to each other. X squared minus 1 equals 2x plus 7. So I want to figure out when do they intersect with each other. I'm looking for those 2 points. So I'm going to go ahead and solve this by putting them all on one side to make it a quadratic. So I'm going to do x squared. I'm going to subtract 2x from both sides, so minus 2x, and then subtract 7 from both sides, so minus 8 equals 0. Now I'm going to factor. So I get x, and then 4 times 2 gives me 8, and I want it to be negative. So negative 4 plus 2. So x equals 4 or x equals negative 2. And then, so that would be what our x-intercepts are for that quadratic. However, these are just the x values, right? This is going to one form a line and the other will form a quadratic. So we're looking for those 2 points where they intersect. So if we know what the x values are, we can plug them in to figure out what the y values are. And you can plug it into either equation because you'll get the same answer. So 4 times 2 is 8 plus 7 is 15. So that would be 4 comma 15. If you put 4 in here, you get 4 squared is 16 minus 1 is 15 as well. Then we're going to put negative 2, which would be negative 2, comma, negative 4 plus 7 is 3. Same thing here, negative 2 squared is positive 4, minus 1 is 3. Then I will show you as well, you can also always, of course, graph this. So if you put in the equations 2x plus 7 and x squared minus 1 and graph them and look for the intersects, we can do second calc, look for the intersect, right? So we have negative 2 comma 3. That's one of the ones that we got over here. And then the other intersect, let's see if we can get it to, we need to zoom out actually. Let me do that first. Looking for that one there. And so we get 4 comma 15, which is what we got there as well. Okay, so you can use your calculator to do it. You can also mathematically do it. This says, what is an equivalent form of the function negative x squared minus 8x minus 12 that reveals the zeros? So if it reveals the zeros, it should be factored. A and B are in vertex form, so they're not factored, but we want to look at the zeros, so it has to be C or D. Now, when we do this, what we can do first is FOIL and then distribute that negative. And so we would get negative times x squared plus 6x plus 2 is 6 plus 8x plus 12. And if I distribute that negative, I will get negative x squared minus 8x minus 12. So looking at this, it appears that it is C. Here, what would happen is in the middle, we would get a negative 8x, and then multiplying a negative times a negative would give us a positive. And so that's why this one does not work. Let's look at the zero property of multiplication. So anything times 0 equals 0. So the point of this is that when we're looking for the zeros, if we find one that equals 0, the whole thing will equal 0. So that's why we set each factor to 0. So solve for the zeros of these equations. So 2x squared minus 12x plus 18 equals 0. So this is the equation that we did up here above. So I already have my factors. It's 2x minus 6 times x minus 3 equals 0. And so now I'm going to set each one equal to 0. So 2x minus 6 equals 0, and x minus 3 equals 0. And so now you can solve for x. Okay, you can do the same thing with this one here. We already have the factors up here. So all you need to do is solve. So I'm looking for you to have your own answers here. Okay. All right. Moving into reading a quadratic in vertex form. So remember, vertex form gives us h and k that are the vertex, h comma k, and that is the vertex. Remember that the negative is part of the equation, so if it is negative, it's going to actually move to the right, and if it were x plus 2, for example, it would move to the left 2 units. Okay, that k moves it up or down. If it's positive, it's going up. If it's negative, it goes down. And then you know if you have a negative in front of the parentheses where a is where the coefficient is, then it is going to be open down. So this is, what is the equation for g of x? Well, we know that it can't be a or b because this is open down, it's frowning, so we have a negative coefficient. That leaves us with either c or d. What we want to look at here then is, what is the vertex? The vertex in this one would be 2, 1, and in this one be negative 2, 1. And so that tells us that d is our best answer. All right, it says the vertex of the equation is in this form where a, h, and k are constants. Write the function in vertex form, fill in the missing numbers of the vertex form of the function, enter your answers in the boxes. So what I'm first going to do is factor out this 3. So I'm going to rewrite this as 3 times x squared minus 6x plus 7. And now I want to write this in vertex form. So in order to do that, I need to complete the square. So I'm going to go ahead and say, actually, hold on just a second. I got too excited. I did something wrong. So first, before I factor out that 3, I'm going to move the 21 to the other side. So negative 3x squared plus 18x equals 21. Factor out that 3, x squared minus 6x equals 21. And then I'm going to complete the square. So taking half of 6, which is 3, squaring it, I'm adding 9 to both sides. But remember, I'm also adding whatever I multiply negative 3 by. So 9 times negative 3 is negative 27. So now I have negative 3 times x squared minus 6x plus 9 equals negative 6. And then I'm going to write this as negative 3 times, remember I just made this a perfect square, so x minus 3 squared. And then I'm going to add that 6 back over here because I want it to be in vertex form. So this will be negative 3 times x minus 3 squared plus 6. And that means that I have a vertex of 3, 6. Now, if you want to as well, you can double check, of course, by looking at your graph. So let's go ahead and take a look at what that looks like on your calculator. Right, so if I want to graph this here, I can put in negative 3x squared plus 18x minus 21 and graph that. And then let's zoom. Let's go ahead and zoom in. Okay, and so now we can look at where this vertex is. 3, 6 looks pretty good to me, right? So we can do second calc, and that's our maximum because it's facing downward. I'm gonna move it up as close as I can, and then move it to the right. Hit enter, and we get 3, 6. All right, so that is where we are going to pause today. As a reminder, if you need to put something that is in standard form to vertex form, you're basically completing the square, right? And to complete the square here, I moved 21 to the other side, factored out that negative 3. Then to complete the square, we take half of our middle term, half of b, and we square it. And the reason we do that is because we're forcing it to be a perfect square. So then when we factor that, we can rewrite it as a perfect square and therefore write it in vertex form. The other key point you need to remember is that if you have a multiplier outside of the parentheses, then you need to make sure that you multiply that through and add that number to both sides. So we're not just adding 9 here, we're actually adding negative 3 times 9, so we're adding negative 27 to it. All right, and then you can move that term back over to the left once you've completed the square so that you have it now in vertex form. So we have 3, 6 as our vertex. All right, for extra credit and just so that I know you listened to the video, if you listen to the video, then underneath this problem, you can write I love math. If you write I love math underneath there, as I look at your packet, I'll know that you watched the video. All right, happy homeworking, and I will see you tomorrow.